All right, we're going live. So welcome everybody. My name's Peter Hansons. Welcome to the Sydney DBT meetup. It's fantastic to be able to get together in person, and I'm really impressed with how the numbers have turned out tonight. I was having a chat with Kelly on Slack, thinking, maybe the rain was going to keep everyone away, but thanks for bearing with us, and it's just really great to be able to network and meet each other in person after a good few years. So thanks so much. We've got two really awesome talks tonight, which I'm really happy to bring to you tonight. Mike Robbins, co-founder and CTO of Poplin Data. I think you do a lot of snowplow and all the rest, web analytics. So he's going to be taking us through the DBT on DBT, which is modeling the new structured logging format as events. And then we've got Dean Jackson, who he's the CTO and data dev at Agility, and they're going to be taking us through a couple of their, sort of first couple of DBT projects, and works in the energy sector, greenhouse gas measurements and things like that. So that's going to be a fantastic talk. You can see a couple of banners just there about DataEng Hack and DataEng Bytes. I run another meetup called DataEng Hack, DataEng Meetup. We've got a DataEng Hackathon coming up on the 28th of April. If you're interested in the data engineering field, you might want to check that out. Tickets are like $49, and I think it's going to be a really fun day down at the Microsoft Reactor, so that could be really exciting for you indeed. But that's pretty much it from me. At the end of the meetup tonight, once we've closed out the live stream, might do just a round of jobs or whatever. If anyone's hiring, anyone's looking for work or something like that, just feel free to stick your hand up. We'll pass the mic over to you and you can do a bit of a shout out for yourself. I believe SafetyCulture are hiring. Thanks so much for hosting us tonight. The pizza and the beers are excellent. Round of applause for SafetyCulture, in fact. I was informed at some point what the dog's name is. The Spot. There you go. Make sure you say hello to Spot at some point during the meetup tonight. But other than that, we're just going to have two back-to-back talks, finish the live stream, and then continue on for another half an hour of networking. So thanks so much for turning up, and enjoy. Over to you, Mike.
Thank you. Share screen. All right. All right. Thanks, everybody. How's it going? This is nice. I haven't done a meetup for a long time, so it's a little novel. Thank you, everyone, for turning up, and hi, everyone online. So today, I'm going to talk about DBT. So Pete, a while ago, asked if anyone wanted to do a talk in March, and I thought, I don't have anything to talk about, but I'll volunteer. You're about to see the results. So this is DBT on DBT. I'm kind of excited about this because once upon a time in DBT land, not really that long ago, three months ago, let's call it 3 months ago, we used to have this logging format. You ran DBT in your CLI or even in DBT Cloud, and you had these kind of unstructured logs. They were pretty, there's green stuff in there, so you know what's going on, but it was very hard to parse. How are you going to kind of store this information and use it in any way? It was kind of difficult. You could probably do some regular expressions. You could try and parse it out and figure what's going on, but it was kind of hard to use. So DBT1, there's now a JSON format. So there's this new beautiful format with more braces in it, and it now goes from human readable to machine readable. So I thought, what can we do with this new fancy format? And I was very interested in DBT state at this point. I really wanted to start kind of historically storing this information. So we start with the logs. They're interesting. It's a 4-digit code, and it's prefixed by a letter. They're roughly alphabetical, but they skip letters because I don't really know why. And they have a number associated with them. So everything you can do in DBT has a logging thing associated with it. There's about 200 different events. So typically you'll see some of these when you run DBT normally. If you run in debug mode, you'll see all of these. And they have these codes associated with them. But that's all you get. That's all you get in the message. So you get a message there, you get some data, which is just a key value pair, but primarily you're operating on this code. So we can see the Z code here is miscellaneous, so I don't know what that's doing. E040, E is a database adapter, so we can see that it's doing something with BigQuery, but we don't have any mapping. So the mapping itself is all stored in the code base. So if we have a look at how this is captured, there's 230 odd events in DBT. They're all use these data classes in Python. So you can see here we've got kind of an interface. We've got a little typing, very nice code base, Python types. That's a big plus. They've all got a code associated with them. So how do we get from a code to something nice like print pass test result, which is the thing that we actually care about? You could use regular expressions if you really don't like yourself and want to spend a lot of time writing regular expressions. You could write them out by hand, but 230 is a lot to do. So we try and capture them in a different way, which is we use abstract syntax trees and the magic of abstract syntax trees. So we pass the source code, we look at every single class definition, we try and find where it's defining a code variable and we strip it out, and then we put it into a DBT seed. So now we have a really nice mapping between what the code is in the error logs and what the actual error message is. So is it a connection failure? Is it a successful test? Is it a failed test? So it gives us a lot more information rather than just that 4-character code. But it doesn't give us enough, right? If we have a look at these messages, we can see that we're missing a lot of information. We get kind of this message thing, and it's got a bit of information about it. But actually what we really care about is how many tests are passing, how many are failing, how many are getting skipped. At the moment, it's encompassed in our kind of message line there. So we actually want to get a little bit more detailed. We don't have names of anything in here for the most part. We do have an invocation ID. We're going to get back to that because that's really important. But we don't have enough information there. So we need more. How do we get more? We use the output files of DBT. So DBT outputs a whole bunch of files after you run of it. One of them is manifest.json, important, contains all the nodes. So this is all your models, all your tests. It's also got your macros, your metrics, props if you're using metrics, also new in V1, also got your sources in it as well. So this is a JSON file that encompasses all of this information. It's the same on local, it's the same on DBT Cloud. We're also going to use run results. You're probably more familiar with this file. This is the results of every single run that you do in DBT for that single run. So if you run a new DBT run results gets cleared out, never to be seen again. But you've always got these two artifacts with every run. So if you log into DBT Cloud, you run something, you'll find there's a whole bunch of artifacts there. 2 of them will be manifest.json about all the nodes and models that you've run, and the other one will be run results, what's happened in that actual run. So that contains our names, our materializations, our raw SQL, our compiled SQL, all sorts of debatably interesting stuff. Interesting to me. So how do we capture this? That's kind of the hard part. Can we use a macro or post hook? Not really. We can run SQL in a macro or SQL in a post hook, but you have to deal with this Python object. It's not JSON at this point. We could insert JSON into a database. We can't really insert a Python object into a database. So we need to be able to do something with it. We need to make it cleaner. So what if we use HTTP requests? That's a good idea, but you can't execute HTTP requests within a data model. I mean, if you use external functions, maybe you could, but we're not going to do that because that seems kind of dangerous. Instead, what we're going to use is Snowplow. So Snowplow is a behavioral events platform, and it's already embedded into DBT already. So if you have anonymous statistics enabled in your DBT packages, any of them, this information gets sent to DBT at the moment. So they collect this information around who's using what versions, how they're building things. It's all anonymized, so there's no model names in there, there's no user IDs, there's no IP addresses, anything like that. But we don't have to install an extra dependency in DBT because it's already packaged with DBT, and we can just reuse it. So we're not going to intercept their events because that's kind of cheeky and they want to capture those events. But what we're going to do is we're going to piggyback on the library to send those events to our own endpoint. And that allows us to stream those events in real time. It's easy to do. We do a couple of imports. Again, it's already in the namespace. We don't have to add an extra package, so we're not making a big change. And then we run with our new, beautiful, lovely log format, and we pipe it into a parse logging file. So this file is pretty simple. It's not really doing a lot. It's basically 50 lines of Python. So all we're doing, this is not fun. Okay, we're making a self-describing JSON. So we're making an event. We're reading from std in, and we're sending it to Snowplow. What we're sending to Snowplow is every single log event, and then we're waiting until the end, and we're sending all of the manifest and all of the run results. Both of these have schemas associated with. So we're basically kind of sending a whole bunch of JSON. Because we're interested in that JSON, we want to persist it, we want to store it for our own historical record. So if we run that, we can do that. You know what? Let's run that. Big shout out to Corey for helping out with this, because we previously weren't able to screen share. So thank you, Corey. This is much better when it's live, because then I can show you a live demo that has a 50% probability of working. So what are we looking at? I'm running the DBT example models. It's outputting lovely big JSON, and every single line that we get, we're sending an event. So we're sending an event to Snowplow. Once it finishes, we're going to send the run results, we're going to send the manifest, and we're going to get it all in our database in real time. We're streaming into BigQuery. So once this finishes, we can see it's flushing. We're connected to Wi-Fi, so this is probably going to work. There we go. It's worked. Sent all the events. We get quite a lot of logs. So maybe 40 logs per run, depending on how many models you're doing. So we're sending those events. What do we do with the events? Are the events anonymized? We already talked about that. So now we have all this data sitting in BigQuery. Run results and manifest both have a schema associated with it. So DBT internally use JSON schema, which means that there's a structure to JSON. It's not just kind of randomly properties and types. It all has a very distinct structure to it, which means if you're using a data warehouse, Snowflake, Redshift, BigQuery, another one, Databricks. What other logos have we got? Microsoft Azure. You're using a data warehouse, one of the great data warehouses from our sponsors. You're going to be able to parse this JSON in some way, shape, or form. And it's robust against schema changes as well, because we've got that information in there. But it's JSON, and JSON in a data warehouse, whatever you may think, is bad. It's bad for performance. It's hard to parse. It's kind of annoying to deal with. So we want to flatten it. And what I'm also going to do is I'm going to join to information schema. So in information schema, we've got a whole bunch of metadata information. In BigQuery, we've got how many bytes we're scanning, what the cost of the query is, what the performance of the query is. So this enables us to build this really nice wide table, powers combined, and we then start running our DBT on DBT. So we have our ordinary DBT models, top turtle. Turtle, tortoise? Anyone know the difference? Turtle. DBT to flatten JSON into a friendly format. So we want to be able to work with this format in a much easier way, and that's not going to be JSON. And then our bottom turtle is we're modeling the performance of our performance model. So in theory, we can do this recursively. We don't, because it'd be a longer talk. So we get this kind of thing that looks vaguely like this. We've got I'm just going to hide that thing because it's getting in the way, isn't it? So we've got our model. Really simple model. So we have three things. We have the query performance. Regardless of database, you're probably going to have information schema. We've got our run results, and we've got our nodes, which is coming from the manifest. We mash it all together using invocation ID. That's really important. So that's a unique ID that gets generated every time DBT runs. And then we're able to generate all this nice metadata out. So we can look at failures. We can look at who's running queries. We can look at how that query is running. I've got cost in there. Has the query execution plan changed over time? So has someone refactored that model to make it more expensive? Is it scanning more data? How flaky my DBT test? Because remember, we've got a log of all of this information, so we can look at that historically over time. So this is evidence that I put in a screenshot to prove that I'm not lying to you. So this is time series for a single model, and we can look at the cost here. I'm running example models which don't cost anything because that's like 2 rows of data. And then I did a really bad query, which I couldn't make cost enough money. So I put extra decimals of precision. So it's cost me a fraction of a cent. And then you can see my example models, my first model, my second model, these are just the DBT examples. This is the execution time in milliseconds because I couldn't get the x-axis to display in seconds. These are bad graphs. This is not my specialty. But we can also look at the query plan. So this is the query plan because we're joining to information schema. We can look at how long it's taking those stages to execute, how many milliseconds it's taking to plan, execute, compile, et cetera, et cetera. We can do all sorts of fancy stuff. Yeah, let's look at what fancy stuff we can do. So we've run the model. That's given us our real-time events. What I'm going to do now is I'm going to run our performance model like this. So this is just the model that we talked about before. And if things work, which they might, I'm not running JSON this time because I actually care about the output. I kind of want to be able to read it in this case. So we can see we're doing a bunch of JSON stuff. We're joining to things. We're just DBTing. And if we DBT successfully and this finishes, we should see an update in our dashboard basically immediately. So that's the nice thing about this. It's a reasonably regular, there we go, we're inserting rows. It's doing something. So if we flick over now to our dashboard in a moment, this isn't DBT's fault. I just write bad queries. Okay, it's done. So let's have a look at a dashboard. Here's one I have prepared earlier. So first thing that we can look at, let's refresh and we'll hope that it works. We've got a lot of rows in here. So there we go. You saw that number update, right? One person nodded. So that should be enough evidence for everyone. We're going to look at the timestamps because I don't want to be dishonest. Oh boy, this is loading so slowly. All right, so we're almost at the last page. And if we get to the last page and the timestamps are vaguely close, which they are, that's in UTC. That's not on me. That's real. It's just trust me on the UTC part. That's our logs from DBT. So we can see all of our logs historically over time because they're in a database. What else can we do? I'm so glad you asked. We can look at individual models if we want to. So this is the cost in dollars. We can look at model revisions. So model revisions is really interesting. We take a hash. Well, DBT takes a hash of the model. So if you change the model over time, you can go, this model performed better, this model performed worse. So you've got this kind of versioning independent of Git. So you can see for this model here, which is both 2 models. Let's switch it down to 1 model. We can see that I made a change on the 28th of March, which made it run immediately. And then after that, it took around about 1.65, 2 seconds to run. So we've got all this lovely historical data here. And then we can look at the model versions. I've made a lot of changes here, so there's a lot of model versions, but you don't have to make a lot of changes. What else can we do? We can do more. We can look at our test results. So these are, some of them are test results. We've also got models in here. So let's just filter down to test results. These are the default tests that you get in DBT. So some of them will fail automatically and some of them will pass. And we can see the passes and failures. So for each model, we can look at the message, we can look at whether it passes or fails, and we can look at flaky tests that might be failing intermittently or failing on a regular basis and go and fix them. What else can we do? We can look at query plans. Everyone loves query plans. I love query plans. So query plans are important because sometimes you might be scanning more data. You might be adding more data to a table. A table might have exploded. You might be doing a full refresh, in which case you probably want to exclude that. But we can have a look at how complex a query plan is and whether it changes over time. And that's really interesting to determine, have we made the model worse? Have we made the model better? Is it doing what we expect it to do? And then finally, for number 5, we can also have a look at how we influence rows over time. So this is, whoa, that's a boring graph. It's not doing anything. But if it was, we could look at how many rows are changing over time. So if you're running a model on a particularly big day, maybe it's doing 1 million rows, maybe it's doing 2 million rows, maybe it's doing 1 billion rows. We don't really know, but you can track these deltas over time. So that's something that I think is kind of powerful because ordinarily we don't really get that ability. We get the manifest and the run results, but it refreshes every single time. So we don't have a storage of that state. So what can I practically do with this? Is this just a thought experiment? No, debatable. Anomaly detection. So this is something we have running at the moment. So this is BigQuery. You can do similar things in Snowflake with pattern recognition. And in Redshift, you can use SageMaker external functions. So we run an ARIMA model with a plus on it because it's faster. And we can have a look and train a anomaly detection model to look at if we're running a model on a regular basis and it's scanning more rows or it's costing us more money, we can send an alert and be like, hey, if you had a look at this model, it's not doing what we anticipate it to be doing. And we can do anomalies in both detections. So this one's on cost. We can say, is it above? Is it below? And we can send an alert. Everything is possible. Monitor the performance over time. Not going to spend a huge amount of time laboring that because I showed you the diagram. This was just the caption to the picture. Work with your team to celebrate corporate success. It seems like a thing that everyone could be doing. And you can also do this. You can impress your colleagues with helpful real-time DBT notifications into Slack. So we got DBT, we got Snowplow, we got a real-time stream. Pick your cloud of choice, including one from our wonderful sponsors, which what's the Microsoft one? Someone help me out with the Microsoft one. Event Hub. PubSub, Kinesis, Kafka, Event Hub, anything you like. Cloud Function, Lambda, Azure something, I don't know, Azure. You can send it to Slack. You can send it to OpsGenie, famed data engineer Miley Cyrus. If you believe in yourself, anything is possible. So let's determine whether that's actually true or not, or again, if I'm lying. So here's my Slack channel. You can see the history here. Let's see if we can run a shell script. Oh, you know what? Let's. Okay, so we're going to run dbt test. We're going to log in JSON because JSON is live, and we're going to pass it in. So let's run it. It's going to run my tests. It's going to connect to Snowplow. It's going to send my log events. It's going to send my run results. It's going to send my manifest. It's going to look a little different because I'm running tests, but the screen's moving, so something's happening. And then, wow, look at that. There we go. That was a Slack message. dbt hasn't even finished yet. That's how fast we are. You could blink and you would miss that, but you don't have to blink because it's happened 3 times because my tests are bad and 3 of them are failing. That's not a bug. All right, so what else can we do? I mean, that's just some of the things that we can do. Yeah, but you can do a lot. You can do a lot with this. So the whole idea is that you really want to have a historical store of everything that happens in dbt. So your run results are important, your manifests are important. You want to determine the changes. You want to determine how that model is changing over time. I've demonstrated this locally, but you can also do this in dbt cloud as well. You're getting the same artifacts from dbt cloud. You can't get the log in this format yet out of dbt cloud, but there's an open support ticket for that. So I'm sure that will be resolved shortly, but you can do all of this regardless of where or how you're running dbt. So I think it's a really powerful mechanism for doing that. So thank you very much, everyone. That's my email address. If you want to be like, hey, how? I'll probably put it up on GitHub. Some of the code's bad, so preface by saying that. But if anyone has any questions, queries, comments, telling me it's a really bad idea and there's a better way to do it, I'm open to everything.
Yeah, right.
Oh, thank you.
Just so comparing this model, have you tried out open lineage dbt integration? Comparing that to pros and cons?
Open lineage is good, but it's too slow, and there's not enough Python in it for me. Okay. I'm a big Python person, and as soon as I see Java, I just want to use more Python. And this was an excuse to use more Python and more dbt. But open lineage is a really good point. So evolution of models, evolution of timing, you can do some of that stuff in here. But really what I wanted to do was kind of piggyback on the streaming analytics that already existed in dbt to kind of do that. But open lineage is a really wonderful way to do this, particularly if you want to track lineage of your sources, your metrics, your exposures as well. Then open lineage is definitely the way to go because that doesn't really touch any of that stuff.
Shot me down in flames. Any other questions?
How'd you get the query plan in there? Was that in the logs?
Yeah, so the query plan basically comes out of information schema. So it's not in the logs itself. I join it to information schema, and that's got the cost, the byte scanned, who the user is, what the project is, all that sort of stuff. And in DBT, sorry, in information schema, it basically gives all of that to me. So if we have a look at query performance here, I've got this quite wide table that is definitely going to load. And we've had a look at preview. We'll see I've got kind of all this stuff here that is in the log. So job IDs, email addresses, states. And for some of these queries, if we go, let's go to the last page for the queries that we've just run. We'll have timelines. So how long each slot is taking to run. In BigQuery, compute is kind of divided into slots. We've also got the stages as well. So inputs, partitioning, repartitioning, shuffling, all that sort of good stuff. Within job stages, we also have a whole bunch of compute metrics, and we also have steps within there. And if you really like fun, you've also got sub-steps. So it's just, again, turtles on turtles on turtles.
Any other questions? Round of applause for Mike.
Awesome. Thank you very much, everyone.
All right. While our next presenter gets ready and swaps out, do you want to stop sharing as well? Just go to stop sharing the screen. Very good. All right. So that was a fantastic talk. Welcome aboard, Dean. Got an even more exciting talk for you. I love hearing from beginners taking their first steps with DBT, because it's always fascinating how they sort of got into it. Dean's a CTO, so I'm sure he's very experienced, but it's very much an encouragement for any of you. If you're first timers, definitely come along and don't be shy to present. You're most welcome. So, but without further ado, take it away, Dean.
Okay. I think I need to do a share here, is that right? Share the screen. Okay. There it is. How many people, hi everyone. Tech stuff's over. How many people are beginners at DBT? Yeah, good, intermediates, dead set legends. Yeah, okay. What were they valued at? There'll be lots of dead set legends soon. Yes, I'm going to talk about green stack and brown stack. So in sort of property development and also in software, a greenfield is, some of us get to do this some of the time. There's no legacy stuff. You can build what you want. The sky's blue. Who's done one of those in the last year? There we go. We have one taker. We have two takers. More common is what's called brownfield development. It can be pretty hard to know where to start. It can be pretty frightening. In the case of a data project, there's a bunch of silos at the back there, and you're already wondering what might be inside those. So the context of what I'm going to talk about is we did a green stack with DBT, and we did doing a brown stack with DBT as well. And for us, it's about trying to achieve these outcomes with the data. So I guess that's my role as CTO, is to make this happen with a lot of the messy data that goes into our systems. So first, the green stack. So it was for Internet of Things pipelines, carrying things like real-time or near real-time electricity data, gas and water metering data. The BI platform is really the only legacy constraint, but not that old, so not that much of a legacy. And probably the most worrying thing is the customer wants the data so they can do all kinds of things. So I said, of course. So we've got our green field, and obviously there's already a few black clouds looming. There's a high chance of precipitation, but I'm 100% sure that it's all going to be perfect snowflakes. So this is our stack that we've got. It's sort of divided into ingestion on the left and transformation on the right, as is the fashion. So we've gone for that sort of little t LT. The platform, the pipeline, the particular one I'll talk about, there's 4 kind of in this stack. I'm going to talk about this one that uses iot-core and goes through, because that one's actually serverless. It's the first serverless thing we've done. So we're pretty excited about that. The reason it needed to be serverless is because there's actually an IoT device out there that's sending in electricity data with MQTT protocol. And if we don't pick it up, it's gone. So customers not going to be happy. So it was a pretty high priority, especially for the first part of that, to be serverless. So at the moment, our company's been around for a while. So we're doing orchestration with all sorts of different things. But we're kind of Snowflake with dbt running on the top here and run with dbt cloud, mostly. So I'll jump right in, and I'll just talk about some of the little features of this with some sort of screenshots from my lovely project. So the first thing that we found was pretty attractive is that we've got all the code in one project, which is pretty nice. So we've got Terraform, which is provisioning the AWS infrastructure. So that's everything from the IoT endpoint that receives the data through to putting that data into S3. So we can deploy that using Terraform. I do have a sneaky little Snowflake folder in there. It's mostly got the sort of the template stuff for how you do the security in Snowflake. DBT Labs, they have like a recommended how we structure Snowflake security. So it's that, and it's not being provisioned with Terraform yet. We still create users sometimes. And the rest of it is DBT. So if we quickly trace through the pipeline in DBT, which is what we're here for tonight, the very first thing we started with was with a test. One of our most troublesome things is dates and times with IoT. You know, the data comes in with GMT. The actual device is in Western Australia. Our people on our team analysing the data from the device could be anywhere. So what do you show? You can't just rely on the browser regional settings to show the data in what's called the local time zone. You also need the wall clock time zone, which is where the actual device is. So there's quite a bit of a focus on that in this pipeline. We did so we've got the classic kind of staging and march that you probably see. Is that right? Your DBT projects mostly have that. We've got a couple of kind of strange ones going on here too. The first one is raw. So we're not using an ingestion product. So we've got AWS dumping the files into S3, and then we're using what's called, this is from back in DBT 14, which is now 0.14, like from external stage macro, which pretty much runs a Snowflake copy into statement. And that's how we're loading data into Snowflake. So not ideal, but for our small company, it meant one less tool, which was good. So we load all that in, and yeah, it's evil Jason, straight out of Friday the 13th, as Mike was saying. The next thing we do is the more classic staging, and as I said, probably the most interesting thing we're doing there is coming up with these 3 different time zones, like a local without a time zone. That's the wall clock time, and we've set it to no time zone, so no system can ever adjust it. No system will ever think, oh, I know better, I'm going to turn that into Sydney time. And then we've got a UTC, and then we've got another one. So we've got the 3 ones that are in there. I didn't turn that into a macro, and I probably should. I've got 4 pipelines running in here. You can see those pipelines here by name. So what we've tried to do is just give them clear names and have them all visible. And as we get better at DBT, we'll do some refactoring there. At the next layer, so that's our staging layer. We started to document, so that's stuff about the time zone. We made sure we put a document in. Brownie points for us there. We have another layer called ODS. And this is probably my old-fashioned Inmon Kimball sort of stuff. It's operational data store, but you can just pronounce it ODS layer because that's what it is. But what we're trying to do there, I guess, is some things that we would nearly always do to our data, is deduplicate it and do things like that. So we've got a thing that gets the latest loaded records, and then it does an incremental load into this ODS. us, that's kind of before the marts. It's pretty much any use of the data, we would want to clean it up that way. And it's really hard, and this is where the requirements made it difficult, because we've got this sort of at least once semantics of the data coming in, but then sometimes the customer might want to backfill it. So even though it's streaming data, it's not like we just get it once and people see it and the next day it's forgotten about. This customer might want to use this to know whether their solar panel met its ROI targets over the last 3 years. We kind of don't know yet. So we've probably tried to be too flexible with this thing, if that makes sense. And then our BI system is Yellowfin, and the approach we went there, so we've got a bunch of standard sort of data mart dimensions, assets and dates and tenant keys and things. And then we decided to go with what we call a sort of a one table model. So we'll join everything together, and that's semantically what needs to be there. And then Yellowfin BI just connects to that, and there's not that many decisions to make in Yellowfin about modeling the data. It's pretty much going to look like one big wide table and drag and drop and slice and dice to your heart's content. And it looks like this. So it's live data, but we run the DBT model once an hour. And you can see there's some interesting stuff happening there. Some reason they fire up the pumps at their pool at 2 o'clock every morning. And then there's quite a lot of activity happening here in the afternoons, and that's potentially an anomaly for them. So that's kind of the starting point. It looks like this. As I said, not very dry. I wish DBT had a thing where the different folders, it could sort of put them into a sub part of the diagram. That'd be good, wouldn't it? Is there such a thing? Can it be written in Python? Next version. But I guess the saving grace is that DBT, we have all the code in one place, and it's so good because then we can focus on a node and we can still see the dependencies. In here, it's the case of everything that depends on that model, and we could go to the other end and click on this one and see all the things that this depends on. And that's just been so good to have. Frustrations, yeah, my green stack's it's looking a bit brown already, isn't it? Another one is, as I said, it's just hard to make a call on those requirements with late arriving facts and backfills and things like that, tending to lean towards too much flexibility. So next thing for this one is to get it onto 1.0. We did a little bit of SQL linting with SQL Fluff, which is a really good product, and it's really coming along. And it does multiple dialects, which is just really wonderful, because we're going to talk about SQL Server in a minute. Yeah, and then with Snowflake, look, honestly, this is not big data yet. It's really a proof of concept for us that's in production with a few meters. So there's things we would potentially do to reduce costs and make it scale a bit better with more data. And finally, we did the stuff there in Terraform, and we're doing an AWS migration to different accounts. So we're going to learn whether that Terraform actually pays off for us. All right, now for the brown stack. So it's 22 years of what's called system of record reporting data. You know, the customer goes, if this data ever changes, you'll need to explain why, because this is how we report our greenhouse gas emissions to our council and to state government and to the federal government. It was started in 2006, and it's on SQL Server. So the usual range of things going on here. Anyone got projects sitting on SQL Server? Yeah, a few. So stored procedures, cursors in stored procedures, cursors at stored procedures. And with us, our job that we just cannot seem to kill off called nightly processing. It does finish within the night, so that's good. It's being consumed in 3 BI platforms, and I'm pretty afraid to touch it. And I wrote a lot of it. So, so what did we do? The first thing I'd say here, with if you need to refactor something, is there's a DBT online course, and it's free, and it's a refactoring course, and it's really good. It give you the confidence to get stuck into it. So a lot of what I'm going to talk about tonight is sort of our angle on that, but definitely need to give credit to that course. So the first thing we did was create DBT exposures, which is kind of just exposures a fairly new feature. It just declares what your things are being used for. So they're these orange things on the right. So we went into our yellowfin system and we went, oh, what are all the semantic things in the yellowfin system? What's it depending on? So we started by modeling those and then writing down looking at the SQL in there and working out which tables it was talking to in our legacy. Put that in, compiled it, and of course it failed because none of the models, it wouldn't even compile because the models weren't sitting behind it. Wrong way. Then what we did is actually just looked through the legacy code and traced back through the lineage of these things and identified what the sources were and started to document those. So every time we hit a source, stopped and made myself document that source. And I had to do that out of self-discipline because the next step was so exciting. The next step was step 3, which was to lift and shift and do a minor refactor. So that was really picking up all the views and tables out of the old system and plugging them in here and getting them working and getting the tests passing. So we put tests at the end of all of these things at the end of the pipe to basically look at what we generated and actually go and compare it row by row, column by column for exact match with what we've already got. Whether that's good or bad, it's the test of the refactoring. And then once that happened, my reward was to, run that test and then commit and celebrate. And I knew if I didn't do the DBT docs first, that I'd just celebrate and move on to the next one because it was actually quite addictive. I was really surprised how joyful it was doing some of this SQL Server refactoring. And then we repeated that until all exposures were done. And that was kind of cool too, because probably with most things you do that, you go back, the first one you do has 6 sources and the second one has 5. And then the next one you go back and you go, oh, there's only one more source I've got to do. So you start to it starts to get a bit faster as you go. You start to feel like your velocity's getting better. So that was good fun. And then repeat until they're all done and happy days, hopefully. So I'll do a few little screenshots just to show how some of the things that happen there. One of the first is I actually decided to, and I'm sure I could have done this with a Git branch or something, is actually put our issue number in there and create a folder inside the DBT project and just copy all the old SQL lock, stock, and barrel, including the stored procedures into there. And went into the DBT project file and made it ignore this folder, this 10 imported folder. And then when we're ready to work on something, pick an exposure, drag all the models we were going to work on into converting, which was like the kind of work in progress, get it all right, get the test passing, and then once it's done, shove it into lifted and shifted. And we kept the old folder stuff. We went tables will still be tables and views will still be views. And we'll look at actually refactoring that out later so that, because DBT doesn't really matter, right? Today's view, you just change the materialization and tomorrow it's a table, or in 2 minutes it's a table. Some other things there is, this is an example of the schema. So this is at the very end of the pipe, what yellowfin's consuming. These are the exposures in DBT, and there's a depends on, and you just say all the things you depend on. So that was the starting point, and compile that. Just do those exposures, nothing else, compile it and watch it fail, and then start building out behind it. This is our sources, the exciting bits next to the green squiggly line there. There's just like pages and pages of it. It's probably crying to be refactored out into separate files too. And there's 2 slides here about what we did. I said we did a minor refactor. And it was really 2 things. It was just staying out of the business logic as much as possible. But the first one was making sure that we had the separate CTEs at the start of every model. So it sort of works like functional programming. You're sort of saying what you're depending on for this model. And then the only other thing we did, look at that, that's a beauty. The only other thing we did was just minor linting, really for indenting, capitalization, things like that. And some of that doesn't quite go on the screenshot there, but for SQL Fluff, there's quite a lot of no QA tags around things as well. So if we hit problems with the linting, we decide keep the momentum going, just stop that rule from linting on that code. We've got to come back and sort this stuff out later. So really, this is the result of the lift and shift. There's still a heap more refactoring to go, because I reckon there's probably 3 or 4 models deep pipeline in that query. We did one macro, and this was sort of to try and mimic what a stored. We had a stored procedure, because we're a multi-tenant company, so we've got data for a whole bunch of clients. And what if we just wanted to reload data for one client? So we've got stored procedures that handle all that with parameters. So we went, just wanted to get a taste of what that would be like in DBT. So we did a model called tenant predicate, and it pretty much is just a substitute for a where clause. So you could put on your DBT CLI line, we could just go tenant equals whoever, and it would just reload their data and leave everyone else's alone. And that was achievable using the incremental materialization, which was kind of nice, just using that tenant key as the unique key. So a bit of a debrief on this one. It was just a lot of setup time. A lot of that was me not knowing Python. You know, my original hope that I could call myself a modern data stack expert by changing my background to black there. So I had to learn Python, and then how to manage then virtual environments in Python, and it was pipenv, and what are they? They've all got V's in them. So I just chose the one without a V, which is poetry, and I love it. And it took me a while, and then I finally, a month later than that, I realized that it's actually not a virtual environment manager, it's a package manager. But I was like, oh, they're different. But yeah, poetry was really nice. Yeah, so lots of setup time, lots of thinking about linting and standards and stuff, and like, when do we get the rest of our team involved in this? If you guys setting up data platforms, you just like, how much do I do before I get people, everyone starts working on it, and we all just start copying what each other did. That's a really hard decision to make, and that's something that I've really worn the price of previously as a CTO. So yeah, that keeps me up. But anyway, we'll involve the rest of the team hands-on. We're thinking of setting SQL Fluff dialect to ANSI, so that even though we're writing in Microsoft SQL language, the TSQL dialect, maybe we go, well, if we don't need anything special to that dialect, let's try and do it. And that'll get us ready if we do want to actually move to a Microsoft Azure MPP sort of platform. Another thing we'll do is move those sources upstream. So what I showed you there, even though it was very long, looks kind of complicated, a bit too small to read, but a lot of these are actually the result of other transformations. So another thing we'll try and do is pick those sources up and move them back to what the real sources are, and then turn these things into DBT models as well. So this thing's probably going to get 2 or 3 times as wide as it is now. Which brings me to my final frustration. DBT, all your model names have to be unique. Like, look at that beauty. That's the name of it. That's the name of a test. I don't think there's that much code in the test itself. I can see why they do it, but I kind of wish there was a namespacing feature or something like that. There's been talk about it on the DBT Discord, but that's never really gone anywhere. To, be able to reuse model names just because it's in a different folder or a different namespace. So anyway, my solution now is the 35-inch LG ultra wide. And if DBT don't sort it out by the 24th century, I've been watching, that show The Expanse, the TV series. I know it's so last decade, but I'm really loving it. And we're going to have this in the 24th century. So who said you can't solve all problems with hardware? So most wanted DBT features, namespacing. I really like what they're doing with the metrics and semantic layer. That's really exciting because it just gets more of that meaning under version control. We have one meaning that we agree on and have it version control. That's so exciting. I said grouping models. On DBT Cloud, I mean, they're working on performance and stability. It would be good if they could support SQL Server with just through a Bastion host or something, like tunneling into our VPC. That'd be good. and a couple of things I'd like to see in the IDE, but overall enjoying it. So finally, like why DBT? You can read what there. I wrote down our values, and then I went, well, why? How does DBT help us live that value? And it kind of does. I mean, because we could choose a point and click end-to-end data. You probably know the names of some of them. You do it all through the web, but I just feel like that's going to get quite messy, and that people have a passion for data and engineering would probably rather be on the learning curve and having their stuff in version control and having a black background with white text on it. So that's why we're doing that. This is why we exist. Yeah, so I know we're going to chat about jobs and stuff, but if you're interested in what we do, come and have a chat with me. Thanks, everyone. Great to meet you all.
Any questions for Dean?
Can you say a bit more about how you did the testing at the end with the exposures? Did you literally have a dump of the previous output and you compared the output that DBT gave? And was it using a standard DBT utils library to do the comparison?
Yeah, it was DBT utils. It's model equivalent models or something like that. Let me have a look. Schema. Stack2. I mean, Mike's a wizard on the keyboard. I can't talk and think and type at the same time. So, yeah, so this is where the exposures are. So I hope this might help explain it. It's a DBT utils equal row count with a fast fail. Because it's probably like, I don't know, it's probably close to 1 billion rows we've got to check. And then we do DBT utils equality. I know that's tiny data these days, but yeah, it's a lot. Sorry. Yeah, they match. Yeah, and it runs on this computer, which is good. Yeah, yeah, and I've tagged them all because they do take quite a while. It probably takes, well, not a long time, but it takes 4 minutes to do all the load. The whole DBT build takes 4 minutes with the tests and everything, and quite a lot of that's these tests. So we tag them, so on the command line we can easily not run them and then run them when we're ready to commit, that kind of thing. Yeah. Yeah, and those model names are just crazy. And they actually throw errors in SQL Server. SQL Server come back and go, you've tried to create a thing that's longer than 128 characters. I mean, I love the product. You can do anything with it. Yeah, so that's how we did. Does that answer your question? Great.
Awesome. Thank you for sharing your story today, Dean. It was nice seeing sort of 2 different examples. I like the use of test for the migration in particular. One question on behalf of the beginners here. What packages did you find most useful or would you recommend we take a look at?
As in Python packages or DBT?
DBT.
DBT packages. Yeah, DBT utils for sure. That's let's have a look what we've got. Let's, who can tell me where it is? Oh, well, that makes sense. Yeah, DBT utils. So this is for the SQL Server stack we did. DBT utils, DBT date, TSQL utils, and I've been playing with the one called Cogen because I think that could really help us to boilerplate get some boilerplate out of the process. Yeah, I wanted to use Great Expectations, but it doesn't really work with the SQL Server. They've changed a lot of that testing so that the testing really relies on, I think it's CTEs within CTEs, and SQL Server can't do that. So SQL Server finds other ways to do it and creates lots and lots and lots of little things in your database and then deletes them.
Question?
I was just going to say, back to your original comment around the asterisks on the discipline to document and test there. If you don't have the discipline like me, you can add DBT meta test into it and then prevent yourself from merging without writing the documentation.
Oh, really?
Yeah, it's pretty good.
Oh, okay. Yeah, I think when we level up our linting, that'll be the next thing. Yeah. Does it just say you need it or you don't have it, or does it? Yeah, sorry.
You can just specify that you need documentation on like
Some
tables and columns,
documentation.
and then how many tests
Yeah.
you need to have. It's saved me
Yeah.
a lot from doing commits that I shouldn't.
Cool. I've got another question for you. Is you document a model, and then because you're encouraged to make this whole pipeline of models, you go back to the one before and it says this model isn't documented yet. And I'd love it just to be able to go, well, if it just pulled that column verbatim from the previous model, then do it in little grey text or something and go, you know, second verse, same as the first. So
I haven't got a good solution for that, but we abuse like shared documentation pretty heavily. So just having like one markdown file with a whole bunch of doc strings and then just reference them everywhere in the YAML. So if you need to update one thing, it just propagates through.
And is that using the YAML? It's the little hat or the YAML thing that pulls in reusable YAMLs.
It's like the curly braces around the doc string.
Yeah, cool. Okay.
That's
all. I might just write down what you mean later so I don't forget. Thank you.
This has been super informative, hasn't it?
Yeah, it's great. I've learned a lot. Thank you very much. Yeah.
Awesome. We might leave it there for questions. Thanks so much, Dean, for that awesome presentation and taking us through like how you got on and took your first steps with DBT. Always fascinating to see. Cool. Lee, should we round of applause? That one's probably open, so give it a shot.
Yeah, it's open. Hey, everyone. I'm Lee. I'm a solution architect at DBT Labs. I just wanted to say hi and thank Peter and Mike and Dean, especially Dean. Where's Dean gone? Yeah, we should talk. I think we share a hobby with causes us to make questionable financial decisions. I saw the sticker on your laptop. Just wanted to say hi. I've spoken probably to a number of you either on Zoom or on Teams over the last year. Maybe when I was at Tableau, I spoke to you as well, where I spent 6 years before DBT. So just wanted to say hi. We're in the room tonight. Kelly's here as well. Hi, Kelly. But yeah, just thanks again to SafetyCulture for hosting us. This is an amazing office. And hiring. You want to do hiring?
Yeah, you can say a quick,
Oh, you're going to pass it around to other people hiring?
We'll do it after.
Okay.
Once the live stream's finished. But
Yeah, we're hiring. And SafetyCulture's hiring. That's about it.
Yeah.
Thank you.
So yeah, Lee, I didn't introduce him very well, but he's from DBT Labs, so solutions architect, right? And based in Melbourne. I think so. Yes. So awesome. Just the final announcement for tonight is that our next meetup, I believe it's like 6th of May. It's at Nearmap. It's in Barangaroo, Tower 2 or something like that. We'll give you a bunch of instructions. Love to see you turn out in such great numbers again. I think it'll be a bunch of really great talks. Might mix things up with a different format for the night as well, but should be a lot of fun. So, and great to see all your faces again in real life. So it's been really awesome. We'll end the live stream right now, but if any of you would like to line up and just